Have you ever noticed that almost every gadget you own runs on a battery? Your phone, laptop, wireless earbuds, smartwatch, flashlight, portable speaker, and even your TV remote all rely on the same type of electricity, direct current or DC. But here's the strange part. The electricity coming out of the wall in your house is usually alternating current or AC. So if our homes are powered by AC, why do electronic gadgets insist on using DC instead? Today we're going to explore why modern electronics are built around DC power, how this all connects to one of the biggest rivalries in electrical history, and why tiny electronic components simply wouldn't survive without it. Right here, on History of Simple Things. Back in the late 1800s, electricity was still a brand new technology, and two different systems were competing to power the world. One was direct current, or DC, promoted by inventor Thomas Edison. The other was alternating current, or AC, backed by Nikola Tesla and businessman George Westinghouse. DC electricity flows steadily in one direction, kind of like water moving through a pipe. AC electricity, on the other hand, constantly reverses direction many times per second. In most countries, it switches direction either 50 or 60 times every second. At first, Edison believed DC was safer and more practical, but AC had one massive advantage. It could travel long distances much more efficiently. Using transformers, power companies could raise AC voltage for transmission and lower it again for homes and buildings. DC systems at the time struggled with this. Because of that, AC eventually became the standard for electrical grids around the world. But even though AC won the battle for power distribution, DC never disappeared. In fact, it quietly became the lifeblood of electronics. The biggest reason electronic gadgets run on DC is because electronic components need stable and consistent electricity. Inside your gadgets are tiny components like transistors, microchips, processors, and memory circuits. These parts are designed to operate using a fixed voltage with current flowing in one direction. If electricity constantly changed direction like AC does, many of these components simply wouldn't work properly. Think of it this way. Imagine trying to fill a glass of water while the water pipe reverses direction 60 times every second. It would create chaos. Electronic circuits need a smooth and predictable flow of energy to process information accurately. Microprocessors inside phones and computers perform billions of operations every second using carefully controlled electrical signals. Even tiny fluctuations can cause errors, overheating, crashes, or damaged components. DC provides the stability these systems require. That's why nearly every modern electronic device converts incoming AC power into DC before using it internally. This is where chargers and power adapters come in. When you plug your phone charger into the wall, the outlet supplies AC electricity, but your smartphone battery cannot charge using AC directly. The charger's job is to convert that AC into low-voltage DC power. Inside the charger are components like rectifiers, capacitors, transformers, and voltage regulators. Together, they transform high-voltage AC from the wall into stable DC suitable for delicate electronics. For example, a typical wall outlet may supply around 120 volts AC in some countries or 230 volts AC in others, but your smartphone usually operates at only around 5 volts DC through USB power systems. The charger safely lowers and converts the electricity before it reaches your device. Without this conversion process, your gadgets would likely fry instantly. Another reason gadgets use DC is because batteries naturally produce direct current. Inside a battery, Chemical reactions push electrons in one consistent direction from the negative terminal to the positive terminal. That creates DC electricity automatically. Since portable electronics depend heavily on batteries, it makes sense for devices themselves to operate internally on DC power. Phones, laptops, cameras, handheld gaming systems, wireless earbuds, and electric vehicles all rely on batteries, so designing electronics around DC became the logical choice. In fact, many modern homes are now quietly filled with DC devices. Even though AC comes from the wall, countless products immediately convert it into DC the moment they're turned on. LED lights, televisions, routers, gaming consoles, and desktop computers all contain internal power supplies doing this conversion constantly behind the scenes. Interestingly, some experts believe DC could become more important again in the future. Solar panels naturally generate DC electricity. Batteries store DC. Electric cars use DC internally. Many data centers also operate heavily on DC systems because they can sometimes reduce energy losses from repeated AC to DC conversions. Some engineers have even proposed DC-powered buildings where electronics could run more efficiently without constantly converting electricity back and forth. USB-C technology is already pushing in that direction by allowing higher-powered DC delivery for laptops, monitors, and other gadgets. So in a strange twist of history, even though AC won the power grid war over a century ago, the modern digital world still depends heavily on DC behind the scenes. Electronic gadgets run on DC because electronics demand stability, precision, and predictable power flow. Tiny circuits inside processors and memory chips can't operate properly with electricity that constantly reverses direction. DC provides the smooth and reliable energy modern technology needs to function. So the next time you charge your phone or power on your laptop, remember this. Even though your home receives AC electricity from the power grid, almost every gadget around you is secretly converting it into DC before it can actually work. In a way, the world never truly stopped relying on direct current at all. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.